Let's see, in my back. All right. Yeah, I don't know. My internet went out for a little bit. Okay, we're going to skip all the programming stuff. Programming. All right. 36. Okay. Setup and operation. Demonstrate understanding of CNC modes for milling. Work coordinate system. Machine coordinate system. Homing procedure and purpose. Workpiece offsets. Tool geometry offsets. Tool wear offsets. Cutter radius compensation. Ways to load programs. Okay. Let's go to the end here. I'll probably read through all the other sections too. Damn, I'm dropping frames like crazy too. Maybe that's just for a bit. Something fishy's going on. Alright, I mean, I've done enough of this all quarter that I feel like machines must be homed in order to recall their positioning. It's good practice to home the Z first, then do the X and Y. Always ensure work holding devices are clean, free of burrs, and secure. Work offsets allow the machine to establish a work zero or origin at a location on the part. Multiple work offsets can be established and activated with G54 through G59. Work offsets must be set prior to setting tool offsets. Z-axis work offsets can be found using a gauge block. X and Y work offsets can be found using an edge finder or dial indicator. Tool offsets for milling allow the machine to understand the location of the tool's tip in the Z-axis. When these offsets are active, the program position will be taken from the tool's tip. Tool offsets for initial setups for unworn tools are entered into the offset geometry registers. Tool offsets for tools that have been gradually and consistently losing their ability to cut the program dimensions have their offsets adjusted in the wear offset register. Milling tool radius values must be entered into the offset pages if automatic cutter radius compensation is to be used. Wear offsets also apply to tool radius values. Programs may be entered into a machine manually typing the program or uploaded from a PC, DNC, or another storage device. Programs may be proven by one of the following methods: graphic simulation, dry run, or safe offset. Okay. This is going to be CNC setup. So for CNC setup, which must be set first, work or tool offset? Work, because you need... Wait, I actually don't know why. because the top honestly, I don't even know if that's accurate because I've never done it that way, but whatever. Which mode is used to manually enter programs? MDI. 3. What is the process called when a program is sent to a machine one block at a time? Oh, do we really need to know that? It's so silly, bro. Is it called single block mode? No, I think it's different, right? Maybe it is. It's got to be single block mode. Okay, explain what may occur that makes it necessary to enter a wear offset. The tool could wear. It's obvious. Explain the purpose of homing. You need to know. You need to find a zero by using limit switches. What is the process called when a new program is carefully executed so that there will be no collisions? Safe run, dry run, prove out. Dry run, typically. What are 2 actions that can be taken during the process in the previous section to ensure safety? I don't know. I don't know. When automatic cutter radius compensation is used in a program, what must be set up in the MCU in order to... You need to have the tool radiuses. Which machine mode allows short temporary program commands to be entered for operations such as spindle starts? Isn't that also MDI? Which machine mode is used to run the machine in a continuous auto? What are the 2 controls in the machine's control panel that control jogging motion? I don't know, handle jog. What control panel feature can be used to slow a spindle speed during a program? That I don't know. Feed rate override, I guess. Okay, cool. Keys and... All right, measurement again. Let me read my notes really quickly. What did he say was going to be on this thing? Axis designation, incremental versus absolute, tool length offset, G43, H values, etc. Controller buttons, G codes, word address programming. G is preparatory, M is for miscellaneous. Ball screws have 0 backlash. Indicator types, continuous and balanced. Cosine error is a thing where the stylus is not parallel to the work surface. What a sine bar is, surface finish and profilometers, optical comparators, and CMMs. Where is that? Is that in here? %, chromium and stainless, UNS unified numbering system. Brass is copper and zinc, bronze is copper and tin. Heel needs to be higher than the clamp. Fixture key, I don't know about that. Let's do the materials section, 158. Metal composition and classification. Learning objectives. Describe the difference between ferrous and non-ferrous. Compare contrast low, medium, and high carbon steels. Define an alloy. Differences, similarities between steel and cast iron. AISI and SAE system of classification for steels. UNS classification of carbon and alloy steels. Classification of aluminum alloys. UNS designations for stainless steels, UNS designations for cast iron, UNS designations for non-ferrous alloys. Okay, let's read the summary now. Now we should do the work holding pages too. Okay. Sometimes metals do not have the desired qualities in their raw state, so heat treatment is performed by controlled heating and cooling to change the characteristics of the material. Hardening is performed on steels by heating and rapidly cooling or quenching. Direct hardening can be performed on steels containing at least 0.3% carbon and hardens the entire piece of steel. Surface hardening is sometimes performed on medium carbon steels by heating with a flame or electric current so that the outer layer becomes hard. Low carbon steels can be case hardened by adding carbon to the outer layer during or after heating to create a thin, hard shell. Fully hardened steels are very brittle and usually tempered or drawn to reduce hardness and increase toughness. Annealing softens metals to their original state by heating and cooling very slowly. Normalizing relieves internal stresses from steels and makes them respond better to other heat treatment processes. Solution and precipitation heat treatment are sometimes performed on aluminum alloys to increase or decrease hardness. Heat treating operations are performed in specialized furnaces that can be powered either by gas or electricity. There are many types and sizes of heat treating furnaces depending on a Rockwell tester is used to measure the hardness level of hardened steels. A Brunel hardness tester is usually used to measure hardness of non-ferrous metals. Ball-shaped penetrator. Both Rockwell and Brunel can be open loop or closed loop. By performing heat treating operations and verifying the results using standard hardness testing, proper material characteristics can be achieved for given specifications and applications. Okay. Wow, so it's all about heat treatment in this. Wait, did I miss a sec? Oh yeah, I did. Lol. I was like, what? Okay, here's the real summary. There are nearly unlimited variations of metals in the world, but they can be separated into two basic categories of ferrous and non-ferrous. Steel and cast iron are ferrous materials. Aluminum, copper, magnesium are non-ferrous. And alloy is a combination of metals. Plain carbon steels and alloy steels can be identified as low, medium, or high carbon steels according to their carbon content. Cast iron is very hard but brittle because it's the highest carbon content. Stainless steels are a special type of corrosion-resistant steels due to the addition of at least 10% chromium. Tool steels are a group of steels used to make tools that work other metals by cutting, forming, bending, or other operations. The AISI system is the most common system for identifying carbon and alloy steels. Aluminum alloys are lightweight metals and frequently identified by the AAIADS numbering systems. Magnesium alloys are also lightweight metals similar to but stronger than aluminum alloys and are identified by the UNS system. Small particles of magnesium are flammable, so care must be taken when machining them. Copper and copper alloys are identified by UNS. Titanium alloys are light, strong, expensive. Super alloys are nickel-based metals engineered for use of under extreme temperatures and corrosive conditions. Oh, geez. The review questions are so easy. Difference between ferrous and non-ferrous contains iron. Briefly describe an alloy has more than two metals. Name 3 alloying elements added to steel. Chromium. I guess magnesium. Nickel. Cast iron is high carbon steel, like really high carbon iron. What element in stainless steel makes it corrosion resistant? I guess it's chromium. It's 10% chromium, so there's a lot of chromium. Small particles of magnesium alloys are flammable. The benefits of titanium are that it's light and strong. AISI stands for fucking something. SAE stands for something else. What are the major alloying elements of 8730 steel? Let's see if I can read a chart. Nickel, chromium, and molybdenum. The carbon content of 87, I think, is 8730 means it's, what is it? It's like point. What does the second number mean? The second number is like the percentage. In hundredths of a percent. So 8730 means that there's 0.30% carbon in the thing. The overall purity of 1030 aluminum, I have no idea. There's too many systems, bro. What the hell? 1030 aluminum. I guess it's... Oh, okay. 1030 is 99.3% pure. Okay. 6061 aluminum. Aluminum, magnesium, and silicon. What do the second numbers mean otherwise? Oh my god. The classification of these metals is, these alloys is crazy. Oh. Oh, hell yeah. Wait, guys, check it out. I got something exciting. I am growing my mathematics textbook collection. Now I can just read a book instead of having to use my computer. Okay, I can read this later. I'm so happy. This is the first math book that I've really gotten. I want to get nonlinear dynamics and chaos. I want to get all sorts of books, but I actually want to work through them. So, one of my goals is to leanify a bunch of this textbook. Okay. $483. Dude, I feel like I don't want to study for this. Like, come on, how hard is this gonna be? I'm pretty sure even if I get like a 50%, I'm still gonna get an A. So, you know. Shoot! Let's just go through all the other questions that we went through before. All right, let's just jump to hand tools. 268. But just see how many of these questions we do. Then I'm gonna end it and just like hang out because it's like, bro, I'm so done with this class. It was the best class ever, but the exams is not the fun part. The fun part is cutting stuff. Okay, summary of hand tools. The ability to use a variety of hand tools correctly and safely is an essential part of becoming a machinist. Choosing the wrong tool or misusing a hand tool can damage the equipment and parts or cause injury. Make sure that screwdrivers and wrenches correctly fit the fastener. Pliers come in various styles and sizes. Adjustable, locked, light duty cutting tasks. Hammers are available in different sizes. Vices and clamps are used to secure materials for bench work. Hacksaws are compact. Portable hand saws that can be used for many applications. Files are available in many different sizes and shapes for deburring and shaping. Abrasives remove small amounts of material to smooth and deburr and can be used to cut hardened steel. Presses are used to assemble and disassemble parts with interference fits. What are 3 safety rules to observe when using screwdrivers? All right. Okay. Oh my gosh, there's so many questions on this thing. Ball peen. Oh, locking are what I call vice grips. The vice grips or locking are sick. That's what I like to use for my pliers. Box end wrench. Oh, boxed end. Okay, yeah. A lot of these are just remembering what the names actually are. Precautions with adjustable wrenches. Fits the bolt snugly. Pull toward you. That's right. I forgot about that. What is one method of preventing damage to a working device? Use soft jaws, probably. When using a hacksaw, get your finger out of the way. Wear safety glasses. Don't cut too fast or put too much pressure. There we go. The blade teeth should go away from you. Safety for a file is don't use files for prying or hammering. They can shatter. And always use a file with a handle so you don't get stabbed by the tang. I love that sweet, sweet tang, baby. Will a single cut or double cut remove material more quickly? I would say single, probably. Okay, no, double cut is fat. Double cut removes more material. Double cut. But a single cut produces a smoother surface. Oh, really? I didn't know that. What is it called? Actually, over the course of this class, I've gotten better at filing. Like, I know, like, what you want to do is you want to, like, if you're trying to deburr, like, a long edge, you want to just go, zoom, and you want to push away from you, go, zoom, zoom, and you just do 2 or 3 good passes, and then you have a good surface. But if you try to go like this, and then over here, it's just going to be uneven and gross. December streams, bro. That's how it is. It's cold. It's actually not that cold this time, but, you know, come February, January. What were the questions? Yeah, with practice and experience, you will begin to develop a sense of what type of file to use for different situations. Oh yeah, loading and pinning. Abrasives are like cloth and stone. I don't know if we have an arbor press. Okay, cool. First section done. Now layout. Layout, we go to 251. Okay, proper layout can be a very helpful guide when performing machining operations, and it makes manufacturing easier. Layout errors can lead to serious machining errors that can result in money and time loss. Semi-precision layout can be used when print tolerances are greater than or equal to 1/64th of an inch. When tolerances are smaller than that, precision layout tools are more appropriate. Always consult MSDS for layout chemicals. Observe safe lifting and handling when moving heavy objects, such as angle plates and parallels. Layout often requires math skills when finding locations that are not shown on prints, but are required for layout operations. Okay, here are the questions. Define the term layout. No. What is the purpose of a layout fluid? It's it's how you see it. Contrast. Consult the MSDS and don't drink this stuff. No, I don't know. Let's look at it. Safety glasses and ventilation. Oh, and no flames. Okay. A scriber is used to make a line. What two angles can be laid out with a combination square? A 90 and a 45. What two tasks can a divider use to be performed? Draw circles, radii, and arcs. Okay. What would the divider setting be to describe a 3/4 inch diameter circle? Probably that over 2. Describe an arc with a radius of that, probably that. Semi-precision layout tool is used to describe a line parallel to an edge at a set distance. Oh. Hermaphrodite caliper? Is that it? I actually have no idea. What tool can be used as a reference plane? Maybe like a surface plate or an angle plate? A surface gauge. What the hell is a surface gauge? A surface gauge is just it's just one of those little pads, right? I don't know what a surface gauge is. Okay. All right. Let me just Google surface gauge. Oh, that's a surface gauge? The surface gauge is made up of a base and a scriber. Okay, well, whatever. Next section, reading prints 229. All right, the ability to read engineering drawings is an essential skill for success in machining careers. Engineering drawings use a system of views, line types, symbols, and notation to provide details about required specification of machining components. Title blocks contain the essential information, part number, part name, tolerance, scale, and the material part is made from. Orthographic projection and isometric views show different perspectives to help in the visualization of part shapes. Tolerances can be expressed in different formats. Class of fit and allowance. When describing the tolerances and relationship of mating parts, GD&T specifies tolerances of form, profile, orientation, location, run out by using feature control frames. Some of these tolerances require reference to a datum or reference surface. Information such as tolerances and scale can be found in the title block of an engineering drawing. What view of a drawing usually shows the most detail? It's the front, I think. Label the views. A is, I guess, the front. B is the top. D is the bottom. E is the left. C is the right. F is the back. The line type used to show edges of an object can be, the line types. Oh yeah, the fucking line types. It's the object line. What line type is used to show that cannot be seen? Hidden line. What two line types were together to show sizes of an engineering drawing? Dimension lines. Dimension and leader, dimension and extension, I don't know. Identify the line types labeled in the print. A, that's a leader line. B, that's a dimension line. C, that's also a dimension line. D, that's an object line. E, that's a hidden line. F, what is that? That's a section line. And G, that's a phantom line. Or it's a center line. It's a center line. All right. TYP is typical or something. I don't remember what TYP is. Okay. This means that if there are 4 holes the same size, multiple identical part features or equal dimensions can be identified by typical dimensions by adding abbreviation tip after a dimension. Equal spacing means equal spacing. 3x means that there's 3 of them. A dimension listed on an engineering drawing is known as the, I don't know. What is the question? A dimension listed on a... Oh, a feature of size? No. I don't know what it's called. That's the thing, though, is like knowing the name of it is stupid. All right, there's limit tolerances. Oh, bilateral, unilateral, and limit. Okay, fair enough. Between a specified and unspecified tolerance. The hell is an unspecified tolerance? Oh, a dimension showed on a print is called a basic size. Okay, I don't know that one. Relationship between sizes of mating parts. I don't know. The plane used as reference for a dimension is called a datum, right? Oh, yeah, feature control frame. Okay. I mean, we did most of them. Reading prints, drilling. Oh. Oh, God. Okay, let's just keep powering through, bruh. Drilling, 296, 301. Drilling, twist drill, flutes, spot drill, countersink, center drill, counterbore, chamfer, reaming, okay, thread types, okay, threads, tap, goodness of fit, whatever, tap types, tap usage, broken tap removal, die use. Okay, cool. 318 to 351. Drill press stuff. All right. Drill press, RPM, feed, upright. Micro drill press. Okay. Tools, tool holding for the drill press. Bits, drill point, lips, geometry, drill body, flutes, chisel edge, dead center. Shank, chuck, Morse taper, reamers, countersinks, counterbores. Whoa, 0 flute countersinks? That's weird, bro. I've never seen that before. Morse. Okay. All right, different tool holding things. What's a V block? Angle plate, T-nuts. Drill press cutting tools are available in different materials. Carbide often used for high production. HSS cheaper. Twist bill and reamer can be broken down into three distinct. First is the point. Second is the body. Third is the shank. Twist bill, points wear. Reamer, remove a small amount, but have better surface finish. Countersink operation is necessary to break sharp edges in the top and bottom of a drill hole. Counter bores may be used to create a recess for a bolt. Sleeves and sockets are used to adapt different size Morse tapers to each other. Drill chucks available in many styles. Hold down clamps, clamp worse, or V blocks used for round angle plates. Hole making at a right angle. Okay, cool. I think all the drill stuff is good. Okay, lathe and lathe work holding. I never understood the 3.8 coefficient of 12 over pi. I think I even asked ChatGPT, I just never got it. All right, next section. Let's just jump on. Well, let's just go through this. This is easy. Okay, RPM calculation, feed rate. I never understood drill feed rate though. Okay, locating hole, center finder. Oh, the freaking wiggler, bro. Hell no, I'm using a DRO. I'm not using a wiggler. That was the worst. We had to use that, man. That was stupid as butt. Okay, spot drilling, pilot hole drilling, peck drilling, through holes and blind holes. Gauge pin to check the full diameter depth of a hole. Height gauge turned out to be the best tool of the whole thing, man. Counter boring, spot facing, chamfering, countersinking. There'll probably be a question on that. Tapping. Tap guide. Cool. Alright, on to introduction to the lathe. Principal operation of the lathe. Functions of the lathe. Parts of the lathe. Lathe size specification. Okay, the headstock. Spindle. Spindle nose. Work holding device. Belt drive lathes. Geared head lathe. Gearbox, lathe bed, weighs, carriage, saddle. Where's the diagram? I could just look up a diagram. Saddle, apron, cross slide. Lead screw, feed rod. Feed rack. Apron. Tailstock. Swing. Bed length. Engine lathe is used to machine cylindrical workpieces. Headstock is located at the left end. Quick change gearbox on the headstock. Ways are the precision ground rails. Saddle and apron are the main parts of the carriage. Carriage travels along the ways. Cross slide provides tool movement perpendicular to the ways. Okay, the tailstock has a Morse taper. Dude, who is watching this, bro? What the fuck? What function does the compound rest serve? I don't know. What two functions can the lathe tailstock perform? Standard is Morse, define the swing and the bed length. Okay. Tools, tool holding and work holding for the lathe. Goals, explain the difference between the universal type and independent type chucks. Explain the function and application of a 3-jaw universal chuck. I don't think I've ever actually used a 3-jaw chuck. We always use those grippers. Collets, mandrels, steady rest, fall over rest. I don't know that. All right, let's keep going. Jaws of independent chucks are advanced independently. Universal chucks retract all simultaneously. 3-jaw chuck is the most common. Chuck key, make sure to remove it. 4 is for they move independently. Okay. Spring collets. I haven't used the lathe in so long, bro. I want to hop on a lathe, man. It's been so long. I want to redo my spindle, but sadly, no time. Or not my spindle, my spool. Faceplate is mounted to the headstock spindle and is generally made of cast iron. I don't even know what that is. Oh yeah, live centers and dead centers. Yeah, that's useful to know. Ooh, you can use a test indicator to check run out. That's useful, man. I didn't consider that. Now that I know what a lot of these indicators and things are, I can read this quickly, and I know. All right, a mandrel is a precision cylindrical shaft that can be inserted through the center bore of the workpiece to secure it for machining. I don't know what that means. I just look that up. Mandrel lathe. I don't fucking know. Oh, interesting. The drive dog. What is the drive dog again? I don't know. There'll probably be something on lathe tool geometry or something, rake angle or whatnot. Make sure I have all my... Yeah. Okay. All right, sawing, 269. Identify sawing machines, bandsaws safely, different bandsaw blade materials, blade pitch, tooth patterns, tooth pattern, blade set, blade width, explain curve, sawtooth geometry, bandsaw blade length, band welding procedure, blade mounting procedure, power hacksaw, bandsaw, horizontal bandsaw, vertical bandsaw. You can break it and make a radius. You can also, least waste, that's right. Carbon steel, bimetal, carbide tooth set refers to the staggered arrangement. And the width of the blade is called the kerf. And it's referred to as the tooth set, right? Tooth set. Then you got the blade pitch. Then you get the blade width. Let me see, where's the diagram with the geometry? There we go. Blade width is number 1. That's, yeah. Okay, the rake is the angle. Gullet, tooth forms or patterns. Regular, skip, hook, band length, band welding, mounting and removal, blade speed, cutoff saw, cold saw, I don't know how much more review I really need to do here. Alright, well, there's not that much left. So we just did sawing. Okay, 403 now. We never got to do any boring bar. Alright, machining operations on the lathe, depth of cut. Machine time calculation, roughing and finishing, inches per revolution, tool nose radius, safety, facing, damn, 100 thou cut at 20 thou per revolution. That's pretty intense cut. I never did that high. I always set my feed rate pretty low. Even if I was doing a 50 thou depth of cut. Although most of the time I was turning, not facing. Okay. How to face, how to turn. Touching off. Adjusting for if the tool is too high or too low. Shouldering combines turning and facing to create a step where shouldering is tough. I've never done shouldering. Honestly, it's always seemed like kind of a mystery to me how you get, how you, because there's no way to move the cross feed and the whatever normal feed. You can't move an X and Z at the same time, is what I'm saying. Okay. Filing, polishing, center and spot drilling, spotting, or center drills, spotting drills, filing on a lathe, hole making on a lathe. Oh yeah, main thing to remember with the hole making on the lathe is that when calculating feeds and speeds, you use the diameter of the drill. Reaming, boring, internal shouldering, bro. What the hell? Thread cutting, never did that. Grooving and cutoff, did that. That was cool. Knurling, did that. That was cool. Grades of knurl. Types of a knurl. Okay. All right. What's next? Milling. All right, 469. Or well, let's just jump through this. Oh, threading? No, let's not jump through this. Taper turning. Yeah, I don't know how to make a taper. Oh, that's how you do it? You offset it with an angle? That's crazy. That's fucking nuts. That's why I say let's use a CNC for all of that. All right, milling. Okay. You got the main parts of it, the quill, the saddle, the table, the knee. All right, those are the Cartesian coordinate. Then the parts of a normal knee mill, vertical knee mill. Got the ram, got the head, the table locks, the saddle. Table crank, saddle lock, column, saddle crank, knee crank, base. Okay, cool. Oh, the turret. Yeah, okay. Okay, and the parts of the head, the low range, the variable speed dial, the spindle brake, quill feed selector knob. I never used the quill feed. I never used the quill feed. Quill stop, adjusting nut, feed reverse knob. Use that. Wait, the reverse knob. What's that? G. No, I don't think I ever used that. Manual feed hand wheel. I don't think I ever used that. Feed control lever, never. Quill, of course. Spindle. Quill lock. Yep, use that all the time. Quill feed handle. Use that all the time. Power transmission engagement crank. Never use that. The High, neutral, low lever, that use that. Speed change hand wheel, use that all the time. Okay, cool. Got it. He's absolutely going to ask a question on whether or not you need to change the speed with it on. I remember I was using a mill. I got yelled at, bro, because I forgot to turn it on. Power quill, head movements, optional features. All right, cool. Dude, without a DRO, this class would actually suck. It like wouldn't even be fun because the whole time you'd just be doing nonsense. Okay, what's next? After after milling, mill operations. So we go to 504. We'll just jump through here. Arbors, carbide inserts, insert geometry, form tools, end mills, chip formation, fly cutter, different form tools, more form tools, T-slot, dovetail, woodruff. Tool holding, drill chucks, Morse tapers, stub arbors, R8 collets, work holding, toe clamps. Is there that one thing? There's that one thing, that fixture key or something. Collet block. I don't know. All right. Mill ops. I'm gonna go pee. All right. Mill operations. Let's just run through this. And then we got 2 more sections. I'm just going to end it and go chill or do something. It's cold out here, man. Mill safety, tramming. Aligning of ice. Speeds and feeds. Feed per tooth. Inches per tooth is called chip load. Locating to a layout edge finder. Locating the center of an existing part feature. Dial indicator. Boring. Boring head. Milling basics. Face milling, peripheral milling, conventional incline milling, squaring a block. Squaring a block is definitely the... I honestly think squaring a block properly is probably the hardest conceptual thing in the whole class. I need to make it a really good animation for, there needs to be a really nice animation on, like, okay, you can't assume any parallel sides. Okay, but I'm not going to read it, though. Bunch of stuff on angles, step milling. I don't even know what that is. Open slots. T-slots, dovetail, woodruff key seats. Radii. Internal radii. Pocket milling. Okay. Climb milling. All right. Thread types. We already went through that. All right, so I guess I'm good. I did all I could do. The rest is up to history. I mean, I honestly just don't think that this exam is going to be, like, crazy hard. And I'm pretty sure I need, like, a pretty low grade to get an A. So it's like, obviously I want to know this stuff, but there's only so much review you can do. Alright, so that's the boring ass stream of today. I think I'm just going to